Okay, so now we're going to start graphing by intercepts in standard form. So the first thing that we want to remember is that we had our x-intercept, and we said that had to be a number in the x spot when y is 0. And then we had our y-intercept, which we said the number had to be in the y spot when x equals 0. So now we're just going to really just put that into practice a little bit. So what we're going to do is if I have to plug in 0 for y over here, what that is going to look like is x minus 3 times 0 equals 4. Now, what happens when I plug in 0 for an x or a y? This term just completely just disappears. So that's going to be a little bit of a shortcut if you want to think about it that way. And remember, x equals 4 is not your x-intercept. That's actually like an equation, so I don't want that. I want you to write it as the actual x-intercept. So my x-intercept is going to be 4, 0 in this case. Over here, now when I have my y-intercept, that means I want to plug in 0 for x, and then minus 3y equals 4. And then, again, even if there was a coefficient in front of the x, that just means that this whole term would go away. I just have to divide by negative 3, and y equals negative 4/3. However, oops, I was almost going to circle that, but we don't want to do that because that's not our y-intercept. Our y-intercept is when I plugged in 0 for x, I got out negative 4/3 for y. So then all we need to do is draw our coordinate plane. Okay, and my x-intercept was at 4, 0, 1, 2, 3, 4. And again, my x-intercept should be on my x-axis. And yes, I do see that mistake a lot. My y-intercept is only at, so negative 4 over 3 is just like negative 1.3 repeating. So negative 1.3, somewhere down here. Take your straight edge and just connect the dots. For a line, all you need, oops, I can't even connect the dots. For a line, all you need is 2 points. So excuse that mishandling of my pen over there. I got 1,000 pens because I like my colors. Okay, so that's your first one. So once you get your two x and y intercepts, your 2 points, you just connect those 2 points, you got a line. That's it. So let's do it one more time. So for part B, now my equation is going to look like 3x plus 2y equals 6. Okay, so for this one, my x-intercept means I am going to have a number in for x when y is 0. This is what I try to tell my students and just try to make it a little bit easier on you. If you plug in 0 for y, which is what you should be doing, this whole term just goes away. It's kind of called the cover-up method for those of you guys who have heard of that. So your y value is going to go away. I just want to solve for x. So I really just have to set 3x equal to 6 and then solve for it from here. Divide by 3, la-di-da. X equals 2, which means my x-intercept is going to be 2, 0. The same thing for my y-intercept. I want to solve for y when x equals 0. So when I plug in 0 for x, that just makes this whole thing go away. 3 times 0 is absolutely nothing. So you're just pretty much setting your y term equal to 6. And that cover-up method, usually it only works for standard form, so just be careful about that. But it's a pretty nifty trick. And then if y equals 3, that means my y-intercept is 0, negative 3. I just have to put that 3 in the y spot. Go to graph this. And 2, 0 is on the x-axis. 0, 3 is on the y-axis. Put down all my pens this time so I can actually draw a straight line. Don't mess it up. Okay. And then there's my line. So I just graphed using intercepts. And usually when you have standard form, this is the method that you want to go about. It's really easy to just graph using intercepts with standard form. With slope-intercept form, it's easier to do it a different method, but we are not there yet. So we will learn how to graph by intercepts with slope-intercept form too. So it's always an option. And yes, you will have to be graphing a ton for your tests, so just keep that in mind. All right, so y equals, oh, this is part C, negative 1 over 2x plus 3. All right, so remember, your x-intercept is when we have a number in the x spot and we plug in 0 for y. So in slope-intercept form, our y is always going to be that first variable that comes up. So I plug in 0 for y, and then I just have to solve for the rest of this. So the first thing I'm going to do is subtract the 3. Negative 3 equals negative 1/2 x. And then hopefully you guys remember that whenever we're dividing by a fraction, we are multiplying by the reciprocal. And the reciprocal of 1 over 2 is just 2 over 1, or just 2. In this case, it is negative, so make sure you are keeping that negative in there. But we're just multiplying by negative 2. Negative 2 times negative 3 is 6, and that is what x is going to equal. So therefore, my x-intercept is going to be 6, 0. Now that's a little bit of work, which is usually why we just graph using the different way. But the y-intercept for these is not that much work, because now I'm plugging in 0 for x and solving for y. And what happens when I plug in 0 for x? Y equals negative 1/2 times nothing plus 3. Again, this whole term is going to go away. So y equals 3, which means my y-intercept is 0, 3. Now, hopefully you guys knew that already. So since this is called slope-intercept form, hopefully you guys remembered that this is your slope and this is your intercept. This guy over here is your y-intercept. Whatever b is your y-intercept. So that's what makes it really, really nice. Okay, so we're going to come over here, draw this out. Okay, so now I have, I hope I have enough room for 6. I should. So 1, 2, 3, 4, 5, 6. I just barely made it. And then 0, 3, 1, 2, 3. It's up here. And then once you connect the dots for this, it's going to be a close one because I just cut it off. And one of the things you should notice is that this slope is, or this line is decreasing, and that is because my slope is negative. If you really were going to graph this one without using intercepts, you would always start at your y-intercept, which is 3, and then you go down 1 to the right 2, down 1 to the right 2. My line's like slightly off, but you can see it does work. All right, so that's just a little foreshadowing for how you should be graphing in slope-intercept form. And then we'll just do one last one over here. So y equals 4 over 3x minus 2. And again, we're just going to graph by intercepts one last time. So my x-intercept is when I plug in 0 for y and solve for x. X-intercept means I have to solve for x. So start by adding whatever your b is over 2 equals 4/3 x. Multiply by the reciprocal, 4 over 3. Oops, or 3 over 4, I'm sorry. Said it wrong, wrote it right. So multiply by the reciprocal, 3 over 4. For this one, when you're multiplying over here, we have 6 over 4. So I can simplify that down to 3 over 2. And that's what x is going to equal. So my x-intercept is 3 over 2, 0. And then I should just be able to know that my y-intercept is just going to be negative 2. So my y-intercept is when I plug in 0 for x. If I plug in 0 for x, that whole nasty fraction just goes away. So y is just going to equal negative 2, which means my y-intercept is 0, negative 2. And beware of that when I give you a test or quiz. If I ask you, what is your y-intercept, and you put this, it's going to be marked wrong. If you just put negative 2, it's going to be marked wrong. If I ask you for your y-intercept, I want 0, negative 2. I have to have a point. Okay, so then over here, I am at 3/2, which is about 1.5 for my x. And then I am at -2 for my y. And then I have this line. And again, notice this line is increasing from left to right because my slope is positive. And if I was going to actually graph this using the other way, I start at -2, and I'd have to go up 4 and to the right 3. And look at that, it was right on the line. Okay, so that's it for graphing by intercepts. Have a great rest of your day.